So yes, this is me at my day job detecting bugs. So I work at WeTransfer as a front-end engineer and team lead. And for me, that means that I write mostly React, HTML, CSS, a little bit of Ruby every now and again. And I also manage a team of 6 and I'm responsible for the day-to-day delivery for that team. And this is also me. About 6 years ago, I was helping run a workshop for young girls in New Zealand, which is where I'm from. And yes, I'm a very long way away from home. But the idea was that we would get these young women into the company to sort of show them what it was actually like to be a software engineer. They were about 14 years old, and they were all in the same tech class at school. And honestly, I think we kind of blew their minds on how cool this shit actually is compared to what they were learning. I really want to encourage people to do as many of these kinds of programs as you can, because it's incredibly rewarding. And also inspirational, because this was one of the inspirations for this talk. Having worked with junior devs quite a lot, it's one of these things that I've noticed is they really struggle with debugging. And I think that's kind of because we don't really teach it as a skill. It's one of those things that you sort of expect developers to just pick up naturally. And there's so much there to learn if you really focus on it. And that's why I decided to write this talk. Hopefully there'll be something useful in here no matter how deep down this hole you've been before. So a quick look at the process itself. How often have you actually spent time thinking about how you debug? It's easy to forget that it's a difficult skill, that it's something that you need to master in order to become a really experienced developer. And it's learned over time and improved with experience. And it's not just about the tools you use, but it's the mindset and the process and how you actually work through your debugging tasks. And it becomes particularly clear when we compare those new developers with more experienced ones. Often new developers will jump straight into the code, they'll go and change a whole bunch of things, they won't remember what they've changed and what they haven't and what actually might have fixed the problem and what was maybe just some extra bit of code that they stuck in there that wasn't useful at all. But it's something we do pretty much every single day. And so in this talk, I won't go into the detail of how important it is to reproduce the bug, be methodical, only change one thing at a time, how to narrow down where the bug is. But it's surprising how often this stuff is not taught. So if you're a junior developer or you're teaching junior developers, I hope you're one of either of these two things, do spend the time really looking into this stuff with them. So there is one step that I do want to cover really quickly, because even the most senior developers I've worked with, and including myself sometimes, I forget to write tests. Like, this is the first thing that you do, right? If you've discovered a bug, write a test that reproduces it, because it not only will keep your focus on just that one bug, it'll also speed you up, because you no longer need to launch your app and click about to get to the state of where your bug actually is. And, of course, it'll help your bug never return. So let's move on to the tools, starting with the console. Well, the polls are in. As you can see, we've got 56% of developers on the left-hand side use console.log and 67% on the right-hand side. And it's not surprising, right? Because we've been conditioned to use it alongside simple text editors like Sublime Text, Atom, Notepad, etc. And a large portion of web developers have also just simply missed the exposure to a formal or structured debugging process, like myself. And the browser console is a pretty nice way to inspect the results of your logs. So it works and it's easy. Well, why change it? Well, because there is so much more. So even if we just take a closer look at console.log, you'll see that there are lots of different ways to optimize it. So here on top, we have the normal console.log usage for logging out these two variables, pin1 and pin2, and here they appear. But on the bottom, if you just add 2 extra characters to turn this log into an object here, you not only get the results of the log, but of the value of the variable, but you also get the variable context. So it's much easier to see at a glance what you're logging. It can be really useful, especially when you're logging a lot of different things in your application. And you can also really easily add styling to your logs. By including this %C at the beginning and then passing through some styling as a second parameter, you can get really pretty colors. So sticking to the console for now, did you know that there are actually a whole bunch of different more methods on that object. So I'm going to show you my favorites, but Googling will reveal a hell of a lot more. For instance, console table is super useful if you want to log out an array of objects. So here you can see it's much easier to kind of compare at a glance the different values. And next we have console group, which is when, I don't know about you, but have you ever ended up adding so many logs in your application that you can't tell which was the one that you just added? Well, group and group collapsed are really useful for structuring your logs into collapsible groups, creating less noise in the console for you to analyze, which is really the aim of the game. Another useful function you can use in the console is the $selector. So it works similarly to the jQuery selector. It's an alias for the document.querySelector function in the console. If you include a 0 after it, as I've done here, you can get the most recently inspected HTML element or JavaScript object. A 1 gets you the second most recently selected, etc., up to 4. Super useful if you want to quickly see what properties or attributes are on the DOM node or JavaScript object that you're looking at. And if you use $, it's the equivalent of document.querySelectorAll. Even better, it returns you a proper array rather than a node list, so you can manipulate it straight away. Console.trace has been a lifesaver for me, especially when you're working in a new code base and you don't have that inherent knowledge of what is calling what. And so in here, I added a console.trace on this handle filter click function to figure out what was calling it. And you can see that it's now telling me that it was called by handle click in filter.js. And console.dir is great when you want to inspect a DOM node as a JavaScript object rather than as its markup, which is what console.log returns you. So you can see all the properties on that DOM node much more easily. In Node, though, it's even more useful. As you can see, console.log spits out the objects in black and white, and it only displays 2 levels deep. Console.dir, on the other hand, allows you to add some really handy configuration. So here we've just added this extra object where we've said colors true, depth null, and it means that we get our logs all pretty with lots of different colors, and you can now access the lat and long properties on that geo object. So let's say we've been working with console functions for a while and want to step it up. Well, let's dive into the DevTools. So I'm going to focus on Chrome because it's what I'm most familiar with, but the Firefox DevTools are also really great and have a lot of the same functionality. Browser DevTools have some really handy features for debugging. So the DevTools debugger is the best one of them. One of the simplest ways to activate this is by using a debugger keyword in your code. So this debugger keyword, I typed this into my editor and opened it up in Chrome. And when I refreshed, it hit the debugger keyword there, that breakpoint. And so now you can see, sorry, I'm having video issues as well, but hopefully you'll be able to see that we can log out the variables in scope at the moment. We can also inspect the entire scope at this point of execution. And we can also step through the code. And speaking of stepping, just in case you've never used a debugger before, here are your main options. They're pretty much the same no matter what kind of language you're writing or what kind of tool you're using. First we have resume, which is when you're on a breakpoint and you press this and you'll be able to resume the script until the next breakpoint is hit. If you hold this button down, you'll also have the option to play through without hitting any more breakpoints, which can be useful when you just want to get the code running. The next is step over, which executes the next function after your breakpoint and stops afterwards. And then we have the step into and out of functions, and note that these are functions that we're stepping over into and out of, not lines of code. That can take a little bit to kind of get that. And yeah, so what we've been doing here is adding a line of code breakpoint with the debugger keyword in our IDE. But if you set these breakpoints in the DevTools or in your editor, you'll see why this can be much more efficient than using console.log. It's almost as if you've peppered your whole code base with console logs without actually having to do so and having to clean anything up. Simply click on the line number. So here I've clicked on 14, 21, and 26. And then run your code as usual. And the execution will stop on your set line of code breakpoints, which you can then press resume to hit the next one and go through, as opposed to needing to step through or over every single function. And when you're doing this, you may also want to use a watch expression. So that's what I've got here on the right-hand side. I've clicked the little plus button there, and I've just decided to watch this .state.mysteries because I want to see what's happening to that data. And then as you step through the code, that expression will update, so you'll be able to see the value of whatever you're watching. There are lots of different types of breakpoints, and you can see these, set these directly in the DevTools. So for example, we've got the line of code, which is what we've just been talking about, conditional line of code, which I'll show in a second, DOM, so if a DOM node changes, XHR, so if you want to break on a particular HTTP request, event listeners, exceptions, and functions. So here on the left, you can see how to add breakpoints just on certain event listeners. So here, just by ticking click there, means that anytime I click on my app, a breakpoint will be hit. And then we have the DOM nodes. So here I'm going to break on when a DOM node's attribute is modified. And then conditional breakpoints down the bottom can be really useful for when a certain function, say a scroll handler or a React render, is called multiple times, but you only want to stop execution when something has a certain value. So here I'm creating a breakpoint that will only be hit if the length of my mysteries array is more than 0. So I here only want to stop when the API has actually returned my data, because I only actually care about the data. For this particular debugging case, I know that the API is returning, so I don't need to stop when the API hasn't returned, but the React render is run. So you can always click on the pause on exceptions button if you want a breakpoint when there's an error. And the tick box to pause on caught exceptions can be really useful. For instance, if you've got a try catch that's swallowing your errors and you're not sure why, then you can find out more about those exceptions. When you have a bunch of breakpoints in your app, it can be useful to disable one or more when you're focused on something specific. So this check mark in the breakpoints list here will just disable that breakpoint temporarily. And in the debugging toolbar, you can disable all breakpoints in case you want to just check how your app runs while you're checking some changes you've made, for example. And a tool that's really useful when you're using the debugger is blackboxing. This lets us prevent the debugger from stepping into certain scripts when we're debugging code. So here I was debugging a React lifecycle function and I jumped into the React DOM library. Well, I can be pretty sure that my bug is not in the React DOM library, so I blackboxed the script. And this way, next time I step through into a function that comes from this file, the debugger will simply ignore it and I can focus on my application code. You can also include file patterns in the DevTools settings to blackbox entire folders, like node modules, for example. Another useful trick when you're really unfamiliar with a code base is command plus \. If you press this shortcut when JavaScript is executing, it will add a breakpoint to the code straight away and stop it executing. You'll be able to instantly see what is happening the moment you press that shortcut. And you can also now add log points in Chrome DevTools, which is essentially a console log that you don't have to remember to delete from your code. The debugger won't pause on these points, but you'll still get the results in the console. Another really useful tool when debugging in the DevTools is the snippets option under the sources panel. Here you can save your own code snippets to run in the console. And there are some really great collections of snippets available online in different libraries. So one of my favorites augments the console with a function called console.save, which you can use and pass anything to it, which then gets downloaded as a JSON file. This is really handy, especially when you have a big JSON object that you want to open, maybe in an IDE, or you want to send it to a colleague, for example. Another useful tool is live expressions. You can click the eye icon here to type something into the console and create a live expression. This pins it to the top of the console and it updates real time. This can be really useful when something in your code needs to respond to a window width or scroll position, for example. And you'll be able to see it update as you scroll down the site. So what about when you want to actually test some of your bug fixing hypotheses? Well, a really great feature in Chrome is called local overrides. So here we go to the sources panel and go to overrides, and we can set them up by selecting a folder on, in this case, my desktop, I think. And we then need to give Chrome access to that folder. And then we can go and change any of the code on this site. For example, this part of the Reddit website, and add whatever we want. So I'm going to add a background color of purple. And now if I go Command Save, you can see I've got this little purple dot up here on the file. And then when I refresh, the changes are persisted, which is really, really useful. If I close the DevTools and refresh, the changes are gone. This approach is really useful for making smallish changes to production websites when you're trying to debug something, in particular when you want to fix something quickly and you have a reasonably good idea of where it is. You don't need to have your local environment running. You don't even have to have the original code on your computer. It can be done with just about any computer setup. So what happens when you want to go further and make bigger changes? That you not only want to persist on browser refresh, but persist to your own project files sitting locally on your computer. Well, the DevTools also have a really interesting feature called workspaces. So here's a little app I made for calculating insulin dosage for diabetics. Note it's a production app on Heroku, not on my local host. So this could be any website, right? So in the File System tab, I can add the folder. This is my actual folder on my desktop for this application. And again, give the DevTools access to it. And now you can see my applications loaded here in the sources panel. I'm going to make a change. I'm just going to add a console log of hi. Why not? And if I save that and go to my IDE, you can see that the file itself has been updated. And I can also go back the other way. So I'm going to add everyone here and see that it's persisted here to the DevTools. This can be super useful and really powerful. And in fact, for some people, it allows them to use just the DevTools debugger DevTools as their IDE. However, it can be a little flaky and it's still not as good as a full IDE in my opinion. In particular, it struggles with more complicated build systems. But if you have a project that you built with Create React app or Vue CLI, for example, you can actually just drag the entire folder onto the sources panel and it's all set up for you. So if you like this idea of being able to persist changes on your production website, there's one last way I want to show you. This is the concept of proxying your production files to local files on your hard drive. Similar to workspaces, but without the DevTools persistence, but with a lot more other features that better support complicated build systems. The simplest is a Chrome extension called Resource Override. So say you have a version of your application running on localhost. Using this extension, you could proxy the call that your production website is making, in this case, on the left-hand side, bundle.js, to the version of that file on your local drive. So that's my local host bundle.js. And this allows you to change your code and test it within the larger environment where the bug actually occurred. Applications like Fiddler and Charles Proxy, which is my personal favorite, also allow you to do this, but with a lot more features, including the ability to monitor and inspect all the calls that your website is making. I've been on teams that have literally used Charles Proxy for their entire front-end development flow. Many big applications can be tricky to set up locally, and trying to keep the back-end architecture and APIs up to date as people are working on them, as well as your own front-end code base across multiple teams, can be a pain in the ass. It can take quite a lot of time. If, however, you have a reliable staging environment that everyone's pushing to, then proxying your front-end files is a nice way to skip that setup entirely. So a lot of the technology I'm covering either is seriously enhanced by or doesn't work at all without source maps. So a source map is a file that allows the browser or other technology to map the compiled or compressed code back to its original file. It's a really important tool that helps with debugging. Minified code is almost impossible to debug properly. On the top, we're inspecting a website without source maps, and you can see all the variables have been mangled and the ES6 class has been transpiled. Whereas on the bottom, source maps have been set up, and it's way easier to understand what's going on because it's the code we actually wrote. And depending on your build process, it should be pretty straightforward to set up. Here's the config for Webpack, and at the top is the way to tell Webpack to use its standard development configuration, which includes source maps by default. If you want more control, you can define it separately. I've chosen cheap module eval because I like the balance between speed and support, but your choice will depend on your use case. Then beneath that, we have the config for production, and the only thing you actually need here is the dev tool property. But if you're using uglify.js to minify your code, you'll want to set source map to true when you declare that plugin. And if you want to set the file name of the source map, you can do that too. When you build your project, you should see your source map file like we have over on the right-hand side. So, what about deploying source maps to production? Well, I am a big believer in doing this because production bugs is when you really want to know what's going on. You're in a hurry and you want to decipher the code pretty quickly. So the good thing about source maps is that they only get downloaded when the dev tools are opened. So they have no effect on your application or on its performance. And if you're really worried about people being able to look at your source code unminified, and keep in mind that security through obscurity is never a good idea, then there's a pretty straightforward solution. So here you can indicate in the JavaScript file a source mapping URL configurable with Webpack that points to the source map that's been uploaded to a different location. Say one that's only accessible by your team, like an S3 bucket maybe that's only set up for your company's VPN to access. And if you're not able to set up source maps, say you're just being nosy and checking out someone else's website, you can always click on the format button to make the code at least slightly more readable. So moving on now to performance debugging, and I do not have time to do it justice because there is so much you can learn about here and it's easily another entire talk, but I wanted to quickly illustrate where you could start. And the key is to find the code that you wrote, right? So these flame charts can be a little bit indecipherable until you actually figure out where your code is. So if you click to open the main panel, you'll see all the activity that occurred on the main thread, including the execution of JavaScript. Usually a lot of the stuff here is found in frameworks, but if you scan through the orange sections, you'll be able to find your JavaScript files, which is usually what you're looking for, right? In this case, it's my main.js file, and note this is a very basic one-page app, which is why it's so small. You can then zoom in further and find the functions in your app, and compare the time that they're taking with each other. Here we can see a call to append child and fetch, which should be a little bit more familiar to us. And the easiest way to debug an app's poor performance is by doing a performance audit with Lighthouse. This is a tool inside the audits panel. Here you can see the results on the same small one-page app. And the best bit here is the opportunities section, where you've got a list of the resources that you should optimize, and it has specific details on how to do so. The audits panel also allows you to audit other things like accessibility, which is really great. It makes something so important so much easier. And if you follow the specific advice in the audit, your app will be so much more usable for so many more people, and in many cases, improve the experience for everyone. Keep in mind, though, there is no substitute for proper manual accessibility testing. So when it comes to debugging specific elements for their accessibility, the elements pane comes in handy. Here you can inspect elements and see which properties are correctly filled out. So in this case, we're inspecting a text input. You can see that the name property is search, and this is what screen readers will read out when the user focuses on this input. You can see that the name was computed by looking at the placeholder property. This input should really have a proper label or an area label, but at least it has a placeholder, so all users will now be able to know what it's for, rather than the screen reader just reading out text input. So the last thing for the DevTools, did you know that you can even debug Node in the DevTools? You just need to run your Node script with the inspect flag. BRK, by the way, means break before the code starts, so that you can add your breakpoints straight away. Then either click on this green Node icon down here on the left, or go to Chrome/inspect and click on Open Dedicated DevTools for Node. If you like this workflow, you should check out the Node Inspection Manager extension, which manages all your scripts and windows for you. So let's get to the really good stuff. Integrated debugging in the editor has been around for ages, but many JavaScript developers are either not aware of it, they think it's too tricky to set up, or they don't want to change their debugging mindset because they don't think it's worth it. Well, I'll let you be the judge, but do give it a go first. Unfortunately, we have a lot more front-end editor options these days, some of which include an inbuilt debugger. I'm going to focus on VS Code because it's super light and fast and it's what I use every day. And I promise I'm not trying to sell you anything because, well, that would be stupid because it's free. But yeah, other IDEs like WebStorm also include an inbuilt debugger. And the idea is pretty similar. I'm going to take you through my debugging process and how I set it up with a mini front-end React app that talks to an Express server. I've added a couple of spelling mistakes to simulate a real bug that you might be trying to fix. So a typical process for debugging a front-end application might look something like this. We open the browser, we see an error in the console, we go to our editor, we log out some of the variables, back to the browser and refresh, or maybe a hot module reload, and if we're lucky, we've chosen a variable that helps us determine how to fix the bug. Back to the editor, make the fix, back to the browser, refresh, okay great, fixed. Well, that's a hell of a lot of guesswork and switching back and forth. I mean, we're used to it, but it doesn't need to be this way. VS Code has a bunch of extensions that let you debug tons of different languages in different configurations. The most useful for us is the Debugger for Chrome extension. It's actually framework agnostic, so you could be working with Angular, Vue, React, whatever you like. But I'm going to show you the configuration for my app. So first of all, I'm going to the extensions and searching for the Debugger for Chrome. I'm going to install that and reload VS Code. And now I can go to configurations and add a new configuration. And I'm going to choose the launch Chrome one here. And I'm going to change the URL to localhost 3000 because that's what Create React App uses by default. And save that. And then press play. And you can see that the app is loaded. There's absolutely no other setup or settings. It's really, really easy. And the debugging experience is also really nice. So here I have a bug because there's supposed to be some quotes showing up in my app. And if I add a debugging breakpoint about where I think that the bug probably is, and then refresh, I can see I've hit my breakpoint, and I can see that quot is undefined. I wonder why. And if I go into the variables here and inspect the actual data, I can see, oh, the data calls it quote. Okay, well, then I can go and edit the variable, fix the bug, remove the breakpoint, and then restart, and hey, it's fixed. And I didn't even need to touch the browser. Obviously, this is a pretty fake example, but you get the idea. So before I finish, I should just quickly mention that in no way have I covered this space. I've obviously had to focus on one browser and one IDE, and I didn't even touch on mobile and network and service worker debugging, to name a few. There is so much more to explore here. And of course, accurate and realistic test coverage is an extremely important and useful way to prevent bugs in the first place, provide a quick and easy way to test fixes, and prevent them from occurring again. The golden rule, my golden rule, whenever you fix a bug, make sure there's a test for it. So the last thing I'm going to leave you with is this. If you want to stick to the good old console.log, then that's cool by me. I still use a combo of different tools, including console.log, but please at least set yourself up with a good code snippet so you're not wasting your life typing it out by hand every single time. And that's it. Thank you.